Hello and welcome to Chemistry Sensei. This is Shane speaking. Today we'll be going through 2016 CHIJ St. Joseph's Convent SA1 end of year paper 1. Before we begin, it will be good that you try these questions by yourself, and these questions can be found in the description box down below. Okay, if not, let us begin. Question 1. Gas W has a molecular weight of 17, very soluble in water, and is alkaline. Okay, straight away option A is incorrect because gas W will dissolve in water. Similarly, option D is also incorrect as it is alkaline. It will react with acid. Okay, so which option should we use? Should we use the downward delivery method, or should we use the upward delivery method? Okay, so we have to determine if gas W is denser or less dense than air. Alright, how do we do that? First, we need to understand what is the composition of air. Alright, air is made up of 78% nitrogen gas, 21% oxygen gas, and the last 1% is for other gases. Okay, so the molecular weight of air is equals to 78 over 100 times the molecular weight of nitrogen gas, which is 14 plus 14, as well as 21% of oxygen gas, which is 16 plus 16. Okay, we do not include the other gases as there are too many gases for us to account for. So this is actually just a estimation. Alright, so once we press our calculator, we will get approximately a value of 29 grams per mole. Alright, when we compare to the the gas W, which has the MR of 17, we can conclude that this is less dense than air. Hence, we should use the upward delivery method, which is option C. Okay, let's move on to question 2. When fine pollen grains are suspended in water and viewed through a microscope, the pollen grains appear to move in random fashion. Alright, for those of you who are aware, this is also known as the Brownian motion. Okay, this motion is the result of, okay, option A is incorrect. It's not caused of the currents in the water. It's also not caused by pollen grains slowly dissolving in the water. Okay, it is also not because of option D, which is the pollen grains moving in a constant random motions in all directions. Okay, if this is true, we will see the pollen grains, alright, moving in all kinds of medium. If you place the pollen grain on the table, it will move, but that is clearly not the case. Alright, for option B just now, okay, this is incorrect because eventually the pollen grain will dissolve. Alright, so that is also not the case. Alright, the correct answer is option C, where the movement is caused by the bombardment of pollen grains by water molecules. This is because in the atomic level, alright, the water molecules are moving at very fast speed. Alright, they are moving at at a very fast speed. And because polar grains are very fine, they will feel the impact of such motion. Alright. Okay, let's move on to question 3. A mixture contains 3 solids: ammonium chloride, magnesium chloride, and silver chloride. In what order should the process be carried out to ensure effective separation of each compound from the mixture? Alright, just by looking at these 3 solids, okay, you must be aware that ammonium chloride is highly unstable. Alright, it would undergo sublimation readily. Okay, so sublimation is the process of changing from solid state to gaseous state directly without having to go through the liquid phase. Alright, okay, so once ammonium chloride reaches the gaseous state, it would decompose readily to form ammonia gas and hydrogen chloride gas. I read this as hydrogen chloride instead of hydrochloric acid. Okay, this is because it only has its acidic property when it is dissolved in water. If it is not dissolved in water, this is simply known as hydrogen chloride. Okay, so as I mentioned, because ammonia chloride is highly unstable, it readily forms into gas. We can use the sublimation method first to collect ammonium chloride. Okay, once that is done, we are left with magnesium chloride and silver chloride. Okay, so from the solubility table that you should memorize, we can conclude that silver chloride is actually an insoluble salt. Okay, so when we dissolve, okay, maybe let me change to another color. When we dissolve magnesium chloride and silver chloride in water, okay, we have magnesium chloride and silver chloride. Okay, only magnesium chloride will dissolve in water. Alright, silver chloride will remain as solid. Okay, so it is the precipitate, okay, found in the solution. Okay, so once we have a liquid, a solution containing, okay, so solution containing MgCl2 and solid silver chloride, okay, we can use this mixture and place them in filtration, okay, by having a filter funnel over here and a conical flask. Okay, so the silver chloride, because they are not soluble in water, they will be the residue and can be collected from the filter funnel. Alright, the soluble magnesium chloride is found here. Okay, so in order to obtain magnesium chloride, we will need to remove water through crystallization. Okay, so the correct answer for question 3 is option C. Let's move on to question 4. The diagram shows the chromatogram obtained by the analysis of a single dye. Okay, what is the RF value of the dye? Okay, so RF value is defined by the distance traveled by the spot divided by the distance traveled by the solvent front. Okay. By looking at the diagram tells us that the original spot of dye is located over here. So this is the starting point, the starting line. Alright. This original level of solvent is not the starting line. Okay. Okay, from here, the original spot of dye, we can conclude that it has traveled a distance of 9 centimeter. Okay, the total distance traveled by the solvent, alright, is 9 plus 3. Okay, 9 plus 3 is 12. Okay, once you simplify this fraction, you have the answer 75. So the correct answer is option B for question 4. Question 5. The apparatus is set up as shown below. Oxygen gas is present initially in the porous pot. Okay, so this is oxygen gas. And the water level was stationary at X. Okay, so here is X. Different gases are then added to the beaker separately. Which gas, when present in the beaker, causes water level at X to rise? Okay, so in order for us to find the correct answer, we need to calculate the molecular weight of these 4 gases. So once we have calculated their molecular weight, we realize that methane is the lightest of them all. Alright, so the correct answer is methane. Okay, we are unable to use other gases because they are relatively bigger than oxygen gas, hence they are unable to pass through the porous pot. Okay, only methane is able to pass through the porous pot because it has similar molecular weight. It has a molecular weight of 16, which is the same as oxygen gas. Hence, it is able to pass through the porous pot, apply more pressure over here, which causes the water level at X to rise. Let's move on to question 6. A sample of solid X melts gradually over a large range of temperatures. However, the liquid that is formed on heating solid X solidifies at 1 temperature. Okay. Straight away, we can conclude that solid X is not a pure substance. Okay, a pure substance only melts at a single temperature. So straight away, option A is incorrect. We can conclude that the liquid is pure because it only solidifies at a single temperature. Okay, and because of that, option B and C are incorrect because they say a mixture of compound in the liquid state. This is not correct. Okay, so the correct answer is option D. A mixture of 2 compounds that combines to form a new compound when fused. So what could the other substance be that reacts with this pure liquid that forms X? Okay, so I believe that the other substance is a gas. For question 7, the melting point and boiling point of substance E are minus 32 degrees Celsius and minus 8 degrees Celsius respectively. Which of the following statements concerning the particles in E is true? Okay, at -4 degrees Celsius, the size of the particle decreases. This is incorrect. Alright, so temperature does not affect the size. Okay, temperature only affects the proximity of the particles. That means how close or how far apart are they. Okay, so I have drawn these three diagrams. The first one is for solid state, second one is for liquid, and the last one is for gas. Okay, so the difference between the solid state and liquid state is, for solid state the particles are packed in an orderly manner, but for liquid state they are packed in a disorderly manner. Alright, for gaseous state they are very far apart. Okay, so let's take a look at option B at -20 degrees Celsius. Okay, at this temperature, substance E is in a liquid state. The particle possesses the greatest amount of kinetic energy. This is incorrect. Alright, only when it is at the gaseous state, then it possesses the greatest amount of kinetic energy, because it has the most freedom for it to move about. Alright, at -33 degrees Celsius, the attractive forces between the particles are the strongest. At -33 degrees Celsius, it is in solid state. Alright, because it has a lower temperature than its melting point. Alright, so it's over here. Because of that, yes, it has the strongest attractive force. It experiences the strongest attractive force because in the solid state, this strong attractive force is what holds them in an orderly fashion. Okay, so the correct answer is option C. Next, question 8. Which is the same for the particles 40 argon and 39 K+? From the periodic table, you'll be able to find this information of potassium and argon. Let's find out the number of subatomic particles for potassium first, followed by argon. Okay, for potassium, it has 19 protons. Okay, it has 18 electrons. Okay, why? Okay, sorry, I forgot to put a plus here, because it has lost one electron to form the cation K+. So initially it has 19 electrons. Once it has formed the cation K+, it removes one electron. It has one electron lesser. Alright, so the number of neutrons, you take the mass number, which is 40, minus away the number of protons, which is 19, you'll get the number of neutrons to be 21. For argon, it has a proton number of 18. The number of electrons is 18. Okay, because for a neutral atom, the number of protons is equals to the number of electrons. Okay, for neutrons, similarly, we take the mass number found over here, which is 40, minus away the number of protons, which is 18. We will get the number 22. So by comparing, we realize that the number of electrons are the same. So the correct answer is option A for question 8. Okay, let's move on to question 9. Carbon has isotope with the relative atomic masses of 12, 13, 14. If ethene C2H4 is formed from these carbon isotopes. Which of the following is not a possible relative molecular mass of ethene? Okay, so we have 2 carbon and 4 hydrogen. Okay, so the lowest mass it could be is using the carbon 12. Alright, so we have 2 times 12 plus 4 times 1, because hydrogen has the atomic mass of 1. Okay, so once we've calculated, we realize that the lowest molecular mass of ethene is 28. Okay, similarly, the highest molecular mass that ethene can have is when both of the isotopes are 14. Okay, so 2 times 14 is 28. 28 plus 4 is 32. Hence, by looking at the options, we can conclude that option D is not possible. Alright, we cannot have the molecular mass of 33 from these 3 carbon isotopes. Okay, for question 10, a solid X does not conduct electricity at room temperature and has a very high melting point. Which of the following statements are possible inferences? Okay, option 1, X could have a giant ionic lattice structure. Okay, this is correct because giant ionic lattice structure does not conduct electricity in the solid state, and because it has strong electrostatic forces of attraction between its particles, it has high melting point. Okay, this is for giant ionic lattice structure. Next, for giant covalent structure, it does not conduct electricity no matter what state they are in. Due to the lack of mobile charge carriers, it has strong covalent bonds between its molecules or particles, and because of that it has high melting point. We can conclude that giant covalent structure is a possible structure for solid X. How about giant metallic structure? Okay. Giant metallic structure can conduct electricity due to the presence of free mobile electrons that act as mobile charge carriers. Okay, so option 3 is incorrect. So the only correct answer is 1 and 2, which is option A. Question 11. Metals have positive ions in a sea of electrons. Which metal atom provides the most electrons for the sea? The correct answer is option A. Why is that so? Because aluminium is from group 3, sodium is from group 1, calcium is from group 2. Similarly, magnesium is also in group 2. Okay, so aluminium is able to offload 3 electrons, okay, per aluminium atom, and because of that it has the most electrons for its C of D localized electron. Okay, question 12. The table shows 4 elements W, X, Y, and Z with their atomic numbers. Okay, so W has a atomic number of 6. Its electronic configuration is 2, 4. Alright, so 2 plus 4 is 6. The first shell we can fill 2 electrons. The second shell we can fill up to 8, and it is the same for the third shell. Element X, it has an atomic number of 9. Okay, so it has the electronic configuration of 2, 7. For Y, it has the electronic configuration of 2, 8. 2 plus 8 is 10. And you need one more, 11. 2, 8, 1. For element Z, it has an atomic number of 17. So its electronic configuration is 2, 8, 7. Okay. By looking at the number of electrons in their valence shell, we have 4, 7, 1, 7. Okay, so that we can conclude W is from group 4, X and Z are from group 7, Y is from group 1. Okay, formula of ionic compound. Okay, one possible compound is YX, where Y will donate 1 electron in its valence shell to X, with both of them forming the stable octet structure. Another one can be Y and Z, where Y will lose one of its valence electron to donate it to Z, so both of them have stable octet structure. Okay, straight away I can conclude that option C is correct, at least for the ionic compound part. How about the covalent compound part? Okay, so we have WZ4. Okay, because W is in group 4, 1, 2, 3, 4. Okay, you will need 4 Z's. So 1, 2, 3, 4. Okay, 4 Z's to share its electrons with, so that it can have 8 electrons in its outermost shell. Okay, so the correct answer is option C. Question 13. In a laboratory accident, a bottle containing concentrated hydrochloric acid was knocked over and its content was spilled on the floor. What is the best method to deal with this chemical spill? Okay, option A, turn on the safety shower to flood the floor with water. Okay, this is not safe at all because you are just diluting the acid, you are not removing the acid by reacting it away. So option A cannot be the answer. Add excess calcium carbonate until no more effervescence is seen. I think this is a possible choice. Reason being, we have a visual cue. Okay, we can see when does the hydrochloric acid been fully reacted away. How about option C? Concentrated sodium hydroxide and detect the endpoint using an indicator. Because you are spilling over a large area, right? You may have neutralized this portion over here when you test it with an indicator, but that may not be in this region. Okay, so there is a lot of region when you need to test using an indicator. So this will not be a good method as compared to B. Option D. Add excess silver nitrate to precipitate all the chloride ions from the hydrochloric acid. Okay, so what makes an acid is the H plus ions. It is not the chloride ions. Okay, it is the H plus ion. If you take a look at your most common acid, we have your hydrochloric acid, your sulfuric acid, and nitric acid, maybe also phosphoric acid. What they all have in common is actually the H atom. Alright, because this H atom, they can dissociate to form H plus. So H plus is the acidic property. So when you are removing chloride ion, you are not removing the acidic property of HCl. So option D cannot be the answer. So the only correct answer is option B. Question 14. Two acids P and Q of the same concentration were reacted with aqueous sodium hydroxide. Which of the following statement explains why a larger volume of P would be required to achieve the endpoint as compared to Q? So the correct answer is option C. Okay, why? First, you need to know that option A and B cannot be the answer. So let's take a look at what is the meaning of strong acid and weak acid. Okay, so a strong acid like HCl, it dissociates fully to form H plus and Cl minus. Full dissociation. How about a weak acid like ethanoic acid? So we have CH3COOH. This is a weak acid. Okay, generally carboxylic acid are weak acid, so it would dissociate partially. So there is a partial dissociation to form H plus and CH3COO minus. So when the reaction goes forward, there's a high tendency for the reaction to go in the reverse direction. That's the meaning of dissociating partially. Okay, how slight is this dissociation? It is really very small compared to strong acid. So strong acid has a close to 100%, if not 100% dissociation. Okay, but for weak acid, the dissociation is very minute. I can't remember the exact amount, but I think it's about around 1%, depending on the type of acid. Why is option C the correct answer? Is because P is a monobasic acid and Q is a dibasic acid. What's the meaning of monobasic acid? Monobasic acid refers to acid that dissociates to form 1 mole of H plus 1. For dibasic acid such as sulfuric acid, it dissociates to form 2 H plus. Okay, because there are 2 H atoms over here. How about for tribasic acid? For tribasic acid like phosphoric acid, we have 3 H atoms over here. It will form 3 H plus. Okay. So for every 1 mole of HCl, I will get 1 H plus. For every 1 mole of H2SO4, I will get 2 H plus. Hence, I will need 2 times the amount of HCl to neutralize the same amount of sodium hydroxide as compared to sulfuric acid. Okay. And that is why the answer is option C. Next, for question 15. A piece of magnesium ribbon does not react when placed in a solution of hydrogen chloride in methylbenzene. Which of the following action would cause a reaction to occur? So this is a metal acid reaction. But if you remember from one of the previous questions, I have mentioned that hydrogen chloride is not the same as hydrochloric acid. The difference lies in the state. A solution of hydrochloride is liquid. It does not have acidic property. For it to have acidic property, it must be dissolved in water. So the correct answer is option A, when we add water and stir well. Okay, thank you for watching up till here. I hope you have enjoyed the video and learned something new. If you enjoyed the video, please click like and subscribe. I will see you soon.